Hello and welcome to this tutorial on AI in battery management systems for diagnostics and predictive maintenance. In this session, we will use MATLAB to build a simple AI model that predicts the state of health of a battery. Here I will explain every line of code, so even if you are a complete beginner, you can easily follow the step-by-step code. First of all, let me explain the code. That is, the step number 1 is, here I am generating a synthetic battery data. Why? Because here I don't have any real-time data or realistic data. If you have your own real-time data, you can use it for this prediction. That is step number 1, genetic. That is generate. Step number 1, generate synthetic battery data. The first line of code is num cycles is equal to 200, which means we define 200 charge discharge cycles, which will be the size of our data set. Second, voltage is equal to 3.7 minus 0.005 asterisk 1 colon num cycles, which means here I simulate the voltage. It begins at 3.7 volt and decreases very slowly as the battery ages, which is realistic behavior. The third line is current is equal to 2 plus 0.2 asterisk random of 1 comma num cycles. Here next we generate the current data. The average discharge current is 2 ampere, but with small random variations to represent load changes. Next line is temperature is equal to 25 plus 5 asterisk random of 1 comma num cycles. Here I am taking the temperature fluctuation. That is, this line simulates the operating temperature of the battery. It varies around 25 degrees Celsius with fluctuations about plus or minus 5 degrees. And at last SoH, that is line space of 1 comma 0.7 comma num cycles. Here I am defining the state of health, that is SoH. We assume it gradually reduces from 100% down to 70% as the battery goes through cycles. Now I am combining it to make it as a table. Therefore, here I am defining the variable, that is battery data is equal to table of 1 column num cycles, voltage, current, temperature, SoH, and the variable name is cycle voltage, current, temperature, SoH, which means here this line combines all the values into a structured table called battery data. Okay, the variable battery data is nothing but it is a table name, making it easy to use it in MATLAB. And next in the last line is display. Okay, here we need to display the rows, that is the first 10 rows to quickly check out our data sets. Display of data, battery data of 1 colon 10, which will display the first 10 rows. Okay, first we will execute this in our live script in MATLAB. First of all, once you open the MATLAB, it will be looking like this. Here you can open the new live script in two manner. One is, that is news equal to live script, or you can click on new live script. That is, if you click new live script, it will be open like this. Here you can click on live editor. Here you can type the text, that is by clicking on this icon text, you can type any text. That is, here I am typing the text like this. That is step number 1. I am pasting it like this. You can also edit or making it bold. That is hitting to bold. You can bold and italic and underline, everything you can do. And once you have done the work, that is once you typed all your information or data, anything, just put the cursor at the end of the line and click on code. Now you can, an area is generated. Here you can script your code, that is you can type your code. That is, here I am copying this code and paste it in that script area. that is, I am pasting it. Now you have completed the step number 1. Now once you completed, you can also, if you have step number 2, once again you can click the text, that is, it will come out of the script area, and now you can run the simulation. Okay, once you run, it will be, that is the result. Then and there, each and every steps can be run, and the instantaneous output can be visualized at the right side. Here I have generated my synthetic battery data, that is cycle, voltage, current, temperature and SoH of 10 rows has been created. Okay, now let me move on to the step number 2, which is step 2, feature extraction. Here also let me explain the code. Here in the first line of code, average voltage equal to move mean of voltage 5, which means here we begins feature extraction. First I calculate the moving average of the voltage over 5 cycles to smooth out noise. And the next one, that is variance, we have to find the variance of current. I am finding the variance. Now I calculate the variance of the current again using a 5 cycle window. This feature captures the variability in the current signal. And the third, I am taking the average, that is the average of temperature. I also smooth the temperature reading with the moving average to remove random spikes in the temperature. And next I am creating a feature table, that is like the previous one, that is table of average voltage, variance of current and then average of temperature, SoH. Like this I have created, that is all extracted features are stored in a new table called features. This includes average voltage, variance of current, average temperature and the target SoH. Now let me copy this and enter in the same live script. Now I am clicking on the code. Once again I am copying this code. I am pasting it here. Now text. Now you can run this code. Here you can see this, the table has been created, that is average voltage, variance of current, that is average temperature, SoH. Everything has been created. The step number 3 is, now we are coming into this predicting steps, that is train or test split. Here that is the first line of code, train size equal to round of 0.7 asterisk num cycles, that is about to splitting the data set. I keep 70% for training and 30% for testing. Okay, and next I am training this data. X trains equal to features of, that is 1 colon train size comma 1 colon 3. These are the format, that is usual MATLAB command or MATLAB coding. We will be entering this coding. Okay, that is the X train is nothing but the input. Okay, next the Y train is nothing but the output, SoH. Here I select the first 70% of rows as training data, and X train contains the input. Now Y train contains the output. And next, now that is the testing data, numeric. This one is numeric one. Here in the remaining 30% is used as a data for evaluation. That is X test is equal to, this is the features of train size, the same thing. Similarly for Y test. In the previous one we have trained the data, now we are testing the data. Okay, once again you can copy this and paste it in this area, and code. Once again you can copy this code and you can paste it here. So you can click on text. Now you can run this. Now the data has been trained and tested. Okay, it has not been visualized, but we can go for the next step. That is, now we are training the AI model. Step number 4. Here In the step number 4, I train all AI model using the given method. Packing combines 50 decision trees, which improves accuracy and reduces overfitting. Okay, that is model is equal to fit ensemble. This the method. Ensemble is the method of x train, y train. Method of back num training cycles, that is 50. Okay, now I am copying this step. Go to MATLAB, paste it. Once again click on code. Now copy the code and paste it in the script area. Once again text. Now you can run this. That is, now we have trained using the AI model. Okay, and next step number 5. Here I am making the prediction. I use trained model to predict the battery's state of health on unseen data set. Okay, that is unseen data set. Y predict, this is our output variable. Y predict is equal to predict of model of x test. Okay, that is the model of x test, the test input variable. Okay, here once again I am copying this. I am pasting it here. Now I am coding the script. Copy this code and paste it in the script area and click on text. Now run. Okay, and then once again, now we are in the stage of evaluating the model performance. Okay, that is step number 6, evaluating model performance. Here in this step 6, I calculate the root mean square error, that is RMSE. This tells us how close the predictions are to the true value of SoH values. That is, a lower RMSE indicates higher accuracy. If the value of RMSE, that is root mean square error, is low, the accuracy will be high. If it is high, the accuracy will be low. Okay, this is the coding, simple coding. We know the coding, and we have plotted the prediction. That is, this is the coding for prediction. We plotted the true value, that is true SoH, is represented as blue circles, and the predicted SoH is represented as red crosses. If two curves overlap closely, the model is performing well. Okay, finally I plot the true versus predicted SoH. Okay, I will display the coding. That is, first of all I will copy this and paste it here as a text, and once again I am entering the script. Step number 6, copying and paste it here, our text. Now run the simulation. Yes, the root mean square of SoH prediction is equal to 0.1, which is nearer to 0. Okay, the error is almost nearer to 0. Okay, this is the predicted outcome. Okay, this is the predicted waveform. Here you can see this, that is on the screen you can see, that is A prediction of battery SoH. Here the x-axis represents test samples. Okay, sorry, the blue circle which shows the true SoH, which decreases steadily as the battery ages, whereas the orange line shows A is predicted SoH, okay, which is a predicted one using the given model, that is the trained model. These uses fluctuates but generally stays in the same range. Here now, that is the root mean square error value is 0.1044, which means which is close to the true value. Okay, which is close to the true value. This is in the same line. Okay, almost in the same line. This shows that even a simple AI model can follow battery health trends, but in real BMS application, more advanced models and real world data would improve accuracy. Now we'll at the end of the video, that is, this is about and that completes our tutorial on AI in battery management systems. We generated synthetic data, extracted useful features, trained an AI model and predicted battery health. The results showed that even a simple ensemble model can capture battery degradation trends effectively. If you enjoyed this tutorial, don't forget to like, share and subscribe. for more MATLAB and battery management system content. Thank you.